All right, my honors geometry kiddos, you chose it, you asked for it. Here comes another honors only section 5.5 indirect proof. So this to me is much more of a higher level thinking idea. And if you take higher level mathematics, maybe in college, you'll do this. But sometimes you cannot complete a proof directly. Like all our two-column proofs, those are all direct proofs. Well, sometimes instead of going directly, you have to go indirectly. And we'll talk about how to do that here. And again, this is a very simple, like getting your feet wet taste of indirect proof. So when you do an indirect proof, okay, it usually involves a statement and its negation, right? So it takes an assumption. And what you're doing is you're trying to create a contradiction. You're trying to assume something is true, but then have it lead to a contradiction. When it leads to this contradiction, your beginning assumption then is nullified. It's ruled false. So what you want to prove is going to be true. And again, that's a lot of words to talk about, but we'll do an example together. So again, when you talk about indirect proof, sometimes it's called proof by contradiction. Most definitely. All right. Okay, so when you're writing a indirect proof, there are 3 key steps. Number 1, you need to make that first assumption, and it's going to be the opposite of what you want to prove. It's the negation of what you want to prove. Okay, so that's easy to identify. Then next, you need to show that this assumption leads to a contradiction. So again, you're going to use geometry here. You're going to do things that make sense, but eventually you're going to contradict. Sometimes you contradict the given. Sometimes you contradict something in geometry, right? One of those two gets contradicted. And then once that happens, you conclude that your assumption, you conclude that your assumption must be false and that what you want to prove must be true. And you just go with it. Fun times. Okay, so this is going to be through Edge Elastic. So I have a proof in Edge Elastic we'll go over together. Just one. Okay, so here's the proof we're going to look at together. It says complete the following indirect proof. So here's my picture. So this given says that segment XY is not congruent, and there's no symbol for not congruent, so I'd use not equals, but it's not congruent to segment YZ. So we need to prove that angle 1 is not congruent to angle 4, okay? So instead of going forward, we're going to go backwards. We're going to do it indirectly. So it says identify your main assumption and then explain the proof. You can type out the math or use the math type square root of X symbol. There is no congruent symbol, not congruent symbol. So I'm going to use this square root of X button to show you, okay? But what we're going to do is we're going to state our assumption, and our assumption is going to be the negation of the proof. We want to prove that angle 1 is not congruent to angle 4. So let's assume for a second, and yet underneath the math type and the symbols, go to the arrow. Let's assume that angle 1 is congruent. So all this is in the symbols, is congruent to angle 4. So this is our assumption. All right, so here comes my proof. So let's say that angle 1 is congruent to angle 4. So I got to redo this math type. Okay. In the picture, in the diagram, in the figure, and again, this is where it gets kind of murky. You can just type it out if you want to. I'll keep using math type. Angle 1 and angle 2 form a linear pair. So they are supplementary. Right, that's the linear pair postulate. So again, I'm okay with you just writing that out. That's fine. You could put linear pair postulate. Okay. The same relationship holds true for angle 3 and angle 4. Again, they're linear pair by the linear pair postulate. Therefore, or we'll say since, and now we look here, we know that angle 1 and angle 4 are congruent. Well, say that angle 1 was 110 degrees. Well, angle 4 would also be 110 degrees. And that would mean that angle 2 and angle 3 both would have to be 70 degrees. They're also congruent. So there's this idea that angles that are supplementary to congruent angles are congruent themselves. So that's what I'm going to say in this next sentence. Okay? So I'm going to say, since angle 2 and angle 3 are supplementary to congruent angles. And then in math type, since angle 2 and angle 3 are supplementary, we know that, yeah, that's just me trying to be a little bit more. We know that angle 2 is congruent to angle 3. And that is it's called the congruent supplements theorem. That's fine though. When you've been doing your delta math, you've seen this as a reason. Okay? Well, now in this triangle, angle 2 and angle 3 are congruent. So look what I do here. If I mark angle 2 and angle 3 congruent, isn't this now an isosceles triangle? Isn't there an isosceles triangle theorem or a converse that says if these two angles are congruent, then these two sides are congruent? So now I'm saying that segment XY is congruent to segment YZ. So I'll write that down. It is technically by the converse, but if you didn't put that, by the converse to the isosceles triangle theorem, we know that, and I would put in math type. So now for the segment, you have to come over here to this decorations. We know that segment XY, go to the right to get out of there, go back to here for the congruent symbol, would be congruent to segment YZ. But wait, look at our given. Our given said that segment XY is not congruent to segment YZ. Oh no, we just contradicted ourselves. However, this contradicts the given statement. So, our assumption is false. Thus, or therefore, what I'm going to say, therefore, angle 1 is not congruent to angle 4. And you'll see me do my poor man's attempt at not congruent because there is no angle 1. Again, it's LaTeX. You don't know that, but it's this backwards slash NEQ for not equals. And again, I just put not congruent. Don't stress yourself out. Is not congruent to angle 4. And I'll put in parentheses not congruent. And there you go. There's the proof. So this is what we call a proof by contradiction. You assume what you want to prove is false, so you negate it. You go through the proof, and you try to arrive at a contradiction. And again, it can contradict geometry in itself, or it can contradict the given, which is what happened here. All right, so you only have 2 of these for your homework in July. So just the best of luck. Do the best you can. If you have any questions, let me know.